So, like I said, we're going to talk about the what and why of DBT today, and like a setup and configuration guide. So, starting with the what and why of DBT. So, as I mentioned earlier, DBT is specifically an ETL tool, and the way DBT markets itself, they talk about, hey, we are the T in the ELT process. Right? If you have a use case where you are bringing data into your platform, like a Snowflake or a BigQuery or, Synapse, probably DBT is not the tool you want to use. When you are actually, then once the data is in your staging environment and you're trying to then create transformations and, create queries to then take that data and create curated data sets for consumption by the BI teams and different data users, that's the main use case that DBT targets. That's the main use case of DBT. And another kind of like a new word you guys might have heard around is the analytics engineer, right? Like that's what DBT kind of sells itself as a tool for. And the analytics engineer is really focused on that role of the traditional data engineer we think about. The traditional data engineer term kind of combines the person moving your data around and into the different sources, and then also creating the data sets that are needed for business consumers, your BI, your data science users. DBT talks about analytics engineer. They're not bringing data in. They're just kind of focused on more kind of closely aligned to the business users that are going to use it. So they are the folks that know your data models. They know like more about the business rules that are going to, present the curated data. And another one of the kind of key factors of using DBT, it's the simplicity of use, and specifically with Snowflake, where like it has is its ability to leverage the compute of the data warehouse it's running on. So we'll show examples of this and how this works, because it kind of simply takes whatever code you write in the DBT server. When you're doing transformations, none of the transformations happen on the DBT server. So you can run DBT on a laptop, right? And we'll talk about different implementations where people are running DBT on the open source CLI version. It's a very lightweight. However, it abstracts a lot of your code into SQL statements and like YAML configuration files. Then it converts it into code and sends it down into your actual kind of data warehouse compute engine to process the actual data transformations and the cleanup of the data to make it into the final kind of reporting layer. And there's kind of the fourth bullet point I have here is about the best practices that the tool has to work with many data warehouses. Theoretically, you can do a lot of this stuff. If it's a matter of just running SQL statements on Snowflake or another engine, you can do that in Snowflake. Why use a tool like DBT? A lot of kind of the reason that customers use DBT is the simplicity, because specifically in a tool like Snowflake, we'll talk about to create a table dynamically. It's not as straightforward, right? You have to write a lot of you can do it, right, to create a table dynamically and load data into it, but there's extra steps compared to how we'll show that DBT does it, right? So it creates more like a simplification around it, and that's the best practices and kind of easy use it promotes. So the image here that I'm kind of just showing is around, kind of the summary of what I said. You've got kind of different data sources on the left side. You're bringing that data in to your data warehouse, and then data then gets transformed, and this is the layer that DBT is sitting in, right? And then DBT, the transform layer is going out to your data consumers. So we talked about like the why of DBT, right? Like why use DBT compared to another ETL tool, right? So we give an example here of using it with kind of Azure Data Factory, right? if you were to use a tool like Azure Data Factory, another cloud-based ETL tool, how does it typically perform the transformations, right? So step one, you kick off a job from Azure Data Factory, a pipeline to then go fetch some data that's in Snowflake. Then you want to perform some transformation on it. So you send a query over into Snowflake, then or any other kind of data warehouse tool, but we're talking about Snowflake. Then the data comes back into your Azure Data Factory or your other kind of cloud-based ETL tools. Then the transformation that you're trying to perform on that data, then that happens in that ETL tool. The compute that's in that ETL tool, right? Then whatever aggregations and computes you're going to do, it's going to kind of do those here in step number 5. Then it's going to get written back into your data warehouse. So as we all know, getting data out of, if we're talking about the Azure and most cloud providers, this could be Amazon and an Amazon ETL infrastructure. When the data leaves the cloud, right, that's when you have charges. You have egress charges. So a lot of the customers, they want to avoid that, right? You don't want to incur, because you're paying all this the compute resources for Snowflake, and you've got your data there. Why do you want to take it out, pay for another compute costs in another platform, and then also incur the additional kind of bandwidth and charges to kind of send that data back into Snowflake, right? Or other tools. So that kind of use case is kind of the sweet spot of using DBT. That's what where it's very attractive. Where it's trying to kind of leverage your kind of data warehouse engine and the compute that you're paying for in place as much as possible. So what are some of the key concepts that I'll cover today? Now, these are not all the concepts that are in DBT, but these are some of the key concepts, like key kind of highlights that I'm going to talk about in this call. And I feel like there are, you'd say the most, like when we're evaluating DBT, these are like the most, I'd say the most kind of the biggest meat, of the tool. There's definitely other things that I'm not covering, but these are, the key things. So you've got DBT, we're going to talk about projects in DBT, right? So, project is basically when you kind of set up a project, it's just a bunch of SQL and YAML files that DBT is going to use to kind of transform your data and kind of configurations, how to connect to your data sources and kind of connection information to then, write to your whatever data sources, data target it's going to be, which in our case is going to be Snowflake. And it has all different folders inside it that are going to have different kind of scripts that serve different functions, right? So one of the folders that's inside a project is your model folder. So what is a model? A model is basically a SQL statement, right? When we're writing code in DBT, it gets materialized as a SQL statement, right? So that's the kind of abstraction of your data that we call a model in DBT. So, and then within the models, there are different materializations, and we'll talk about these materializations. But one is a table. So when we say materialization, it's when you write a SQL statement, the results that get output of that SQL statement can be created then as a table, right? It can be created as a view. It can get created. You can also do incremental runs. So you've got a source table that you're kind of querying off of. There's some setup you have to do based on kind of, hey, when was the last timestamp that something ran? And then you can set up something called Jinja templating logic. They can read the source table, they can identify what's new, and then based on that, it can load your target table, the incremental materializations, using the incremental logic that's available. And ephemeral tables are basically just tables that are like CTEs or temp tables that, based on the code that you have, it kind of, creates a CTE or temp table at runtime, uses it, and then it kind of just drops it. It doesn't get materialized anywhere. It gets materialized just for your session and for your runtime. So another powerful concept we're going to talk about are tests. So a tool like Snowflake, it doesn't really the enforced constraints, right? Like the ACID like primary key constraints, foreign key constraints, those aren't really enforced, in a lot of the data lake technologies, right? So with DBT, you can write, and we'll show this, that you've got a couple of ways to create tests to enforce the functionality that we're used to getting with relational databases, right? Checking for nulls. These are just some of the things I'm going to show you, but there's pretty much anything that you can convert into a SQL statement, right? Any check you can convert into a SQL statement, that can be a test. So if I can write a SQL statement and say that, hey, if this SQL statement is true and it produces any result, right? Any row that gets generated, right? I could query a table and say, hey, if this table in this column produces a result that is, an integer value, right? Fail this model, right? That's one way to do tests, right? So these are kind of extensions to solve that problem of kind of data quality and data issues that we typically don't get with data lakes, and to basically encapsulate them as part of your project so that you can run that code as you're building your tables and your materializations. As part of that, you can create tests and say that, hey, as part of this model, we're going to run a test to make sure, there's no null values, or write a custom kind of test using SQL that checks for something. And if it produces a result, it's going to fail. Or we've got also out of the box, functionality that we get out of DBT where it supports 4 types of tests, which are going to be, which I have listed here in the first bullet points. You've got null. You can check for null without installing anything, without doing any SQL, without doing anything out of the box. This comes with DBT. Doing a null check, doing a unique check. You can specify for a column accepted values that, hey, these are the 5, 10 values this column should have. And you can specify those, as part of your model configuration, or you can check, foreign key and primary key relationships. Now, if you talk about doing, there's other packages that you get, which you can check things like, schemas, like I was saying, that, hey, is this column a certain data type or not? There's a lot of tests that are there, right? And I'll talk through one of the packages that I've got here for the demo, but it's a really a powerful tool to kind of test and check your data. And the fourth concept I'm going to talk about is using Jinja. So Jinja, it's basically it's like a programming language that sits on top of your SQL that you generate, and all that it does, think of it like dynamic SQL. That's the way I think about it, right? If you're writing a SQL statement, right, and you wanted to kind of, do like an, if then else statements, right? Or do a for each loop, or based on if, this condition is true, then process this piece of code. If this condition is true, process that piece of code within one kind of model definition. That's the purpose of Jinja. We kind of use it for I'll show an example of it for the incremental run, how you can use kind of tags in Jinja to kind of build your SQL. But that ends up being like a very powerful tool that's available within DBT to kind of build kind of customizable and dynamic models. So what are the different types of when you get DBT, what are the types available? So it comes in 2 that I've mentioned here. Obviously, there's a Dbt Cloud version, which is basically, as it sounds, it's a version in the cloud. There's no install, and that's primarily what I'm going to be showing here. And there's also a Dbt CLI version. Dbt CLI is basically a command line interface, right? You install DBT via, your command line, and you basically run your packages through the command line. And we're good. The main difference being is that with Dbt Cloud, you get like a web interface, right? Which is it's a much more cleaner interface to interact with your data. You get a query editor. Very key difference. You get a job scheduling and that scheduling capability you don't have with CLI, right? So source control, you can set up source control with both of these, but job scheduling alerting is not there in Dbt CLI version. But the Dbt CLI version does provide you the core features of Dbt. The core engine is the same, but if you want to roll it out for enterprise use, especially we talk about in the healthcare clients, you want to have any enterprise tool, you need scheduling, you need alerting of your ETL jobs that are running, right? Like that's a very key fundamental kind of thing that the Dbt CLI version does not have. Okay, the command line version does not have that. Dbt Cloud does have that. The only thing that's a challenge, especially in the healthcare space with Dbt Cloud, is that it's not high trust compliant. So for those of you who may not know about high trust, it's like a standard within the healthcare. It's got like, I believe, 19 domains that you have to, like healthcare organizations have to kind of pass to get certification. And each of those you get scored from like 1 to 5, and you have to maintain 3 or above. And it has kind of tenets on kind of how you manage your data, how secure, you kind of keep your data around, different like your technology and kind of processes you have in place, like principles like, hey, does your organization enforce the fact that anybody who needs data, only they have access to the data that they need? And there's different certification processes you have to go through. That, as of right now, Dbt does not have, right? But that may change like in the future, obviously. But, there are other workarounds that healthcare customers still use Dbt, even though this feature is not there. And using Dbt CLI, or it's also called Dbt Core, Dbt kind of the CLI core version. We're going to talk about how kind of healthcare customers can still use Dbt using an Azure implementation to make it to get around the limitations of Dbt Cloud not being high trust. So talk a little bit about the architecture, like how data moves, between Dbt and when you kind of build a model or you execute a SQL statement. So I'm going to talk about both with kind of Dbt Cloud and CLI, but basically this is your Dbt Cloud server, right? Within your Dbt Cloud server, you're going to have different projects, and within that project you're going to have different adapters to connect to your different data sources. And all you're really storing within a project in the Dbt Cloud is you're storing your models and your kind of profile YAML files and your configuration YAML files. Pretty much that's all that gets stored there in Dbt Cloud. You also store, and this is where the high trust piece comes in, you store your account username and password kind of connection information to your database. So that is stored on the Dbt kind of cloud server. So when you execute a statement, as we mentioned earlier, all it's doing is passing a SQL statement down to your kind of your database engine. The data is run, and then also the data then the preview of the data comes back into when you're in the web interface of the Dbt Cloud version, right? So no actual data other than like the preview data that comes back is actually stored on your Dbt server. And we'll also show examples of like when you're running the SQL statements in Snowflake, you can see in the history all the statements that are running. So, and the only difference between CLI and the cloud version, that it's storing the same information, the same files, the same YAML files, same SQL statements, but everything is stored locally, right? So if I've got on this laptop here, I've got DBT core installed. In my folder, I've got the, in my C drive, I've got the project that has all my, YAML files and SQL files saved. And using the kind of the command line, I'm gonna, execute a command, and it's gonna use the profile and the kind of the username connection information to my Snowflake account to then send the command to Snowflake to run the commands. So pretty much nothing, that's a perfectly kind of valid implementation that a lot of customers are using, and that's totally free, right? So Dbt CLI is an open source kind of free version you can use that a lot of customers use as well. So we're going to talk a little bit about before we move on more to the demo about using the CLI version, how clients have used the CLI version with Azure. And this is also, you can do with Amazon, but we're going to talk specifically with Azure to get around the problem of, remember how I said there's no scheduling or alerting within Dbt Cloud? You can do, you can do some of the features that, around kind of alerting and scheduling using containers in Azure, right? With Dbt CLI. And I'm going to kind of cite my sources here that there's a GitLab link to the implementation that a developer has implemented. One of kind of the Snowflake partners have implemented it, that has pretty much all the code defined for this, and it's going to be in the slide deck that I'll kind of share via the meetup. But basically the idea of it is you've got your you can kick off your job via Data Factory, and your actual, remember how we talked about the project files are stored, your SQL and your YAML files? Those you can store in an Azure storage, using an Azure storage account. So in a file share within Azure, you can save your project information. And as I've shown here, you can have, project one, let's say team one is working on project one, they could have their project here. Team two is working on project two, they have their project in their own storage account. Team three have their own storage account. And as they're doing their development, right? Developers working maybe locally with CLI, and you can have it so the developers submit their code into your Git repository, and from there you can write code to then submit that Git. It can kind of package it can package your project and push it to the file share, and then from the file share you can actually using Docker containers, create something in Azure. It's Azure container instances, so it's basically an image, okay, that has it's a Docker image that's going to have Azure CLI installed on it. Okay, so you've got a Docker image that's got Azure CLI installed. When you're ready to run your job, you call that Docker image to come down, and from there you write. This is not a simple by any means implementation, but you can have a script, like an entry point script, that then calls your password information that's stored in like Azure Key Vault, so instead of having your passwords and storage account information saved locally, the developer is going to have their password information saved locally to connect to the dev environment, right? But for your production environment, you've got your password information stored in Azure Key Vault, which is like a very secure way to store your password information. That image instance kind of calls that Key Vault to get your password information, and then it takes your project and it also puts it into your container, and then it executes that against your Dbt Snowflake. Now, this implementation, it's defined in a lot more detail in that article in GitLab, but basically it's the containers, each container is going to have its log, right? That each and every run that it does, and you can schedule the containers to run at a specific time. And basically a lot of clients using this methodology, they run Dbt at an enterprise level basically for free, right? Because Dbt CLI is essentially free. And using these containers, they're like the Dbt CLI is a very lightweight application, and it's just a few cents or a few dollars, depending on the type of container job you have to run. It's just a few dollars per run, right? So a lot of healthcare customers have used this implementation because to get around the network egress costs that we mentioned with other cloud-based tools that have Snowflake. They've used the combination of Dbt CLI with Azure containers and key vaults, and file storage combined to kind of execute Dbt. So now we're going to talk about we're going to shift towards the demo, and I'm gonna the bulk of the demo is going to be focused on the Dbt Cloud version. And I'm going to show a little bit about Dbt CLI, but the bulk of it is going to be about the cloud. And yes, go ahead.
Can you move the models back and forth between the CLI and the cloud version? Is it like a file that you can copy?
Yeah, I mean, if it's connected to your Git repository, because the way I have implemented, it's all in your Git. The code's in your Git. Right? So when you set up a project, you have the option to connect to your Git repository, right? So if you're working with Dbt CLI, right, and now all the code and all the development you're doing is obviously if you're developing, obviously it's going to be local, but if you're in an enterprise environment, you're going to have a Git repository. It's going to be in your Git repository. So the code is not, wherever you can connect that Git. You can connect that, right? So I've done mine with GitLab, but you can do it with GitHub or other repositories as well. So the code is not, it's not just there. It's in your, it can be connected to your Git. There we go. So we're going to do the Dbt Cloud and the Dbt CLI version. Just for those, I'm not sure who are on the call could hear the question. The question was, can you move your models around? And the answer, obviously, I said was yes, because if you connect your source to your source control, that's where your code and your model is going to reside. So if somebody online, they want to follow along, there's a couple of prerequisites to this, or later on, I'll publish the video as well if you want to follow along. A couple of prerequisites that I'm not going to talk about here. You got to have a Snowflake trial account. I set up a database, which it's a dev database, and I've got to set up a schema in my dev database, and I've got a role set up that has access to the DB, the database, the schema, and the warehouse. Right, and I've got a Dbt trial account as well, and I'm going to talk a little bit about the Dbt trial account kind of setup, but primarily a lot of that stuff I've already done. I'm going to go straight more or less into the actual the specific developing and materializing the models and doing the tests, within Dbt, and showing you, what the code that I have, and then, how that code is being executed in, in my kind of target database. And basically, for Dbt CLI, I'm going to publish an article after this talk. That talks about Dbt CLI instruction, right? So a lot of the stuff we did in the Dbt Cloud version, you can do in the CLI version. Basically what I'm gonna, but the CLI installation is a little bit kind of more trickier. So I'm gonna write up a blog and kind of share it with, share it within the meetup group to show how to do that, specifically on a Windows machine. I think on a Mac, it's much easier, but I'm running Windows, and the instructions that I'm going to share are specifically around Windows and the setup that I had to do. So let me go into my, just give me just a second to pull up the demo here. Okay, so this is my kind of Snowflake account here. I mentioned I've got a dev database here. Oh, sorry. Let me pull it up over here. Actually, folks on the chat, are you able to see my screen? I don't know, you can type in the chat if you're able to see my screen at all. Well, I am going to assume that is a yes, but I'm essentially showing my my Snowflake here. This is going to be my kind of environment, and the schema that I'm working in is this kind of team A schema. I've got a couple of tests already kind of created here, tables and views, and I'm going to kind of walk through how from DBT I'm going to execute the commands to then come in that they're going to get executed over here. So let me go into my Dbt account here, and let me start sharing. So this is my Dbt Cloud instance. I'll do a little bit of a kind of a walkthrough about it. When you set up your project, the setup in the beginning it makes you do is it makes you do is around here. You're going to define your Git repository, which in my case I've got the GitHub repository. You're going to define your connection, which I've got the Snowflake connection here. And when you define your connection with Snowflake, one thing, if you are actually following along and trying to recreate this, from this video, the options you get when you're trying to kind of create a project is going to ask you for your account, your role, database. This specific account is basically when you create a trial account in Snowflake, the URL that's right before the Snowflake Cloud Computing, between the HTTPS and the Snowflake Cloud Computing, that's your account here. Everything else is, pretty straightforward. You get your role, your dev, your database, your warehouse, and then you give your kind of credentials to log in. You just got to make sure the credentials that you give, they have, rights to the database schema and the warehouse that you're setting up. One other thing, if you're in my case here, I've got a development kind of plan running here, and these plans are free. Obviously, if you want to kind of share with multiple team members, you can upgrade to a plan. But I'm going to show you this with a developer plan. You can get that for free and use it for as long as you want. So let me go back into my project. So when you're actually ready to develop, you go into the kind of the top left here and go into your develop tab. Okay. So I've got here several models over here. And to give you kind of a quick rundown here, as we mentioned, within a project, you've got your models file over here, and I've got all these models that I've created here that pretty much when you install DBT, you get these example models, right? My first DBT training and my second, and then the rest of these I've created here, right? .SQL file. And I've also got some YAML files here, which are kind of configurations on top of my model. And then we've got tests. So as you mentioned, when you kind of create and you set up a test, that via a SQL statement. If I want to write a test and I want to write a SQL statement that if it pulls a row, then that model failed, I would write that SQL statement and dump it here in the test folder. And this is my your project level kind of configuration file. So one thing here is that I've kind of defined, or this is actually out of the box, that it says here that in your example folder, example folder we talked about, anything that's created, it's going to get created as a view, right? So that's like an example of a configuration you can do that by default, if you don't specify what type of materialization you're going to have, it's going to by default created as a view. And so then I'm going to get started with an example. So in this example, it's basically just a it's basically just I've got a bunch of select statements and I'm kind of unioning the data together, right? And nothing complicated here. So I'm going to create this as a new model, right? So I'm going to go into model and you create a new file, and I'm going to call it, Dallas BI test.sql. So whenever you're creating a model, you have to specify the extension of the model as a .sql file. Otherwise, when DBT is kind of running your models and trying to create the objects and your source, it won't know what type of object it is. It won't know what to do with that file unless you give it the proper extension, right? So, and when you type the dbt command, to run something, it's going to execute everything that's in this model folder, all the .sql files, right, that are available. You can execute all of those, when you do your runs, when you do your dbt runs. So I'm going to do a create here. So as you can see, I've kind of connected this it's connected to Git, so I have to commit it every time. So I'm going to call this, I'm going to copy the same code I had before. I'm going to add another row here. I'm going to call this, I'll leave it as 8, patient 8, and current date. So, I can preview the data here, and this is what I was talking about. This query is being run against your Snowflake engine. This is running against Snowflake, and it just brings the preview result. None of the data is actually none of the compute is being used from like DBT itself. It's all in Snowflake. So I'm going to save this. I'm going to then commit it. Now I can type in a command to run this model, right? Dbt run. Now, if I just do dbt run here, it's going to run every single model that's available in my models folder, right? Anything with a .sql, it's going to run that. But I can specify, hey, I just want to run select, and it was Dallas BI test. Test. And I can execute just this model. So let me go ahead and enter. So this is going to run. And this was successful. So now I'm going to go back into my Snowflake page to show you the model getting created. So within my Snowflake, so you guys noticed here before I had, so I haven't refreshed this yet. So you see that Dallas BI table wasn't here before, right? So now that I executed it, see, where is that? Is it here? Yes, the Dallas BI test is there. So now this table exists here, and if I do select star from, and I run this, oops. You see my rows in here, right? The 9 rows that I created. So now in my specific example, I basically just ran it with a materialization of I ran it with a materialization of as a table, right? I could run the same thing, you know, as a view or incremental, and you know, that would it would know, and it would show up under the view tab in Snowflake.
You know, this is just a block of SQL statements.
Yeah.
Why do you have to run the SQL statement using the Dbt instead of run the block of SQL within Snowflake?
So yeah, that's a good question. Yeah, that's a good question. So the thing is, and this is the same thing which I had kind of wondered before, is, let me share my screen here. So if you actually, let me, if you have to create a table dynamically, remember how I was saying, behind the scene, I just give a select statement in my DBT. Behind the scene, it just knows what to do to then run the SQL statement as a table or a view or a, you know, like an incremental, right? For me to do like a dynamic, like a table creation here, let me bring this over here. You know, it's not that, like, you know, it's because that's the same thing I thought, you know, like you can do in SQL Server, you can write a stored procedure and you can create a, you know, a create table statement. And then in there, you can do insert select into and you know, insert records into a table, do updates. That's possible, but it's not as simple. So this kind of blog here talks about, you know, to create a dynamic table and, you know, within SQL, there's, you know, you got to write like there's a lot more complicated code you have to write to create a table, right? So with DBT, all you have to do is just write that select statement, right? And the things that we haven't talked about, where I think you'll kind of get more convinced, is once we get to the tests, you know, when you see that how easy it is to write tests and kind of check constraints in your data, and doing the equivalent in a stored procedure in Snowflake, or like a function in Snowflake, right? How, and then another kind of really like cool thing, you know, that we that was going to get into is it builds the DAGs, right? So when we start talking about using like the incremental tables, for example, right? Or you've got different stages of data processing you're doing, right? Remember I showed you that DBT run command? That DBT run command already knows, hey, if I have this Dallas BI test table that I just created, there's another table that's dependent on it, right? I can reference different tables using, there's like a ref tag that we'll kind of talk about in a bit. We use the ref kind of tags, these are Jinja tags that already know, hey, these are my dependencies. I can't run this or execute this without executing this first. And that DBT run command, that's all I have to do. Automatically, it'll know all the difference. How much coding do you have to do within stored procedures to say, hey, every time I code, hey, this table is dependent on this table, make sure you don't run it before this table runs. In my pipeline, I would have to manually schedule everything to run this before this, right? This with DBT, using those ref commands, everything can get referenced. Same thing with tests, right? I can have a test, and that test can be part of my schedule, right? I can have a, you know, run my SQL and then run my test, and that pipeline won't pass until the test pass also, right? And I'll kind of show you like the packages and the way to do those tests. and how much effort, would be to kind of replicate those tests within, in a stored procedure, or write custom code to do those, right? So I think once you see some of those, and like I said, those are the exact same things that I was thinking that, hey, you can just run this code and, like SQL Server background, right? Like you just run this code in SQL Server. It's you can do all those things, but a lot of those things are possible, but the implementations, it's a lot more steps to do the same things, as much as DBT kind of makes it easy for you to do, right? So like I said, this was just one kind of in my own research. I was researching, hey, how can you do this? How can I create a table dynamically, insert data in? And this is the implementation I found. I know there's others, but over here, when you write a stored procedure in, in Snowflake, you can write it in SQL or using JavaScript, right? And the implementation I found here, you're writing JavaScript and then, writing, it's not as easy as doing it in, as like SQL Server, for example, when I did it, or, as easy as DBT makes it. Did that answer your question? And we'll cover more.
Probably just because I this type of scenario that I do. So,
I'm sorry?
I don't think I'll have gone into the scenario that multiple stages.
That those scenarios aren't applicable, you said, for you?
I haven't gone into that scenario.
Okay, okay.
But if there's so many stages, I think probably
Got it. That's interesting. No, that's an interesting point. So let me kind of go back into the my DBT case. So the next thing we were going to talk about is using tests in DBT. So within my DBT folder, as I mentioned, I've got this test file here that is gonna that I can kind of use this constraints.yaml file that I can use to create tests against my model that I just created, right? So within that, as you can see, there's different tags. It's a version. Hey, which model do I want to create this test on, right? So in my case, it was Dallas BI test, and I'm testing unique constraints and that it's not null. And you guys might remember I had a the ID column had 8 2 times in it, right? The new row that I inserted in it, it had from the number 8 appeared twice in there in my ID column, right? And I'm saying that here for this test, I want this test on the ID column, and I want to have a test of it being, the column has to be unique and it cannot be null. And that column wasn't null, but we know that it's not unique, right? So I'm going to save this and I'm gonna commit this. And I'm going to do a DBT test. So now here I'm specifying the model that I want to do the test on, and this is the DBT test command to basically execute this test now. This should fail on the unique. So you see over here, the unique constraint, it failed. But the not null constraint, this passes, right? So, using the tests, this gives me that ability to set that up. And then we talked about using, tests with using like a SQL statement, to do a test. So, so I can say any code that I can write that, as we mentioned, gives you a result, that can be a test, right? So in my case, I'm going to do, select star from my Dallas BI test where ID equal 1, right? So this is going to be my test that if it gives me a 1, this should fail, right? I'm going to run this again, and we should see. See, before it was just those 2 tests, the not unique and null, and all I had to do was give the command for that hey, run a test on that table, right? And I remember I have this ref function over here that just says the Dallas BI test, and automatically it picks it up and it'll say, hey, this SQL statement that's associated with the Dallas BI test table it gives a result and it fails it. And then we said the not null still passes, and the unique constraint also it fails as well. So, and then kind of another example I will show of tests. I remember we talked about having like different packages you can do for schema, like making sure your schema is enforced, on a specific column. So for that, I downloaded this package, Dbt expectations, and this is a package that's available, online to kind of install. You can reference that package, basically in your packages.yaml file. You basically have to create a file in the same kind of tree as your model folder, and call that packages.yaml, and you have to put in that dbt basically this code, and then you to install this package. And for this, there is a link here. I'll kind of share on my screen as well. A second here. So basically, I've got the Dbt expectations package. So this package has, as I mentioned, you put this code in that packages, in that packages file, and then you run the command dbt deps to install the package. And basically, it gives you all these different tests, right? Do we expect the column to exist? Do we expect rows to have, certain data, missing values? The column value has to be in this set. It has to be, between, string matching. You can do aggregate functions, distribution functions. So there's a lot it gives you the option to do in terms of testing. And essentially, let me go back to my DBT here. I've got this package already installed that lets me do all those things. Then I've got a Dbt expectations, test expectations YAML file. This is going to make sure that, hey, I've got this pat name column, right? And I'm going to change this to Dallas BI. Dallas BI test. And I'm going to save it, commit it. And basically all I'm saying here that, hey, that I want to use this test that expect column values to be of type. And then I say here that the column value type should be a varchar, right? So, so as you saw, my this pat name column is a varchar. So this should, this should not fail. So if I do another test, so sorry. Mistake here somewhere. Sorry. Oh, okay. So I'm trying to, I have two files that are referencing, two YAML files that are referencing the same model. So, it doesn't like that. So what I will do is I will go ahead and I will go ahead and add this. I'll show this example with another table that is not I'll show it with this example. So I'm actually showing it with this table. This table is also the Seha names perm. It's the same kind of structure that we originally kind of copied this from. The pat name also is a varchar. So we're also, we're just saying, hey, this table should have this, test that pat name should be a varchar. And I'm gonna commit here. Change, so the test, because I'm testing a different model now, I'm gonna give a, the model name is gonna be different. And it does not have all the other tests that were associated with the Dallas BI tests. It only has that, that varchar test associated with it. So this is gonna pass. So, the last thing I'm going to show on this example is going to be around kind of the incremental loads. So remember we were talking about doing incremental runs on and incremental materializations. So you've got I've got this particular code here. This is another model I've created. It's called Seha_Inc. And it's referencing, I'm going to reference here. The Dallas BI test. Okay. So what I'm saying here is that this particular model is going to be an incremental, and it's going to be based on that Dallas BI test model that I just created. And now this is that kind of Jinja templating that we were talking about earlier. And I'm saying that, if this is a particular SQL statement is materialized as incremental, then the load date that I'm pulling from this Dallas BI test should be greater than the max load date that's in this table, meaning this table is the incremental table that I'm creating. right? So this is going to create like dynamic SQL in the background that's going to check the max load date that I have in my original table. And then it's going to go ahead and load only the rows that are greater than the date that already exists in there. So this particular one, if I run this test, so, and I will actually show what's already in that table. So if I've already saved this, no, I haven't saved this. So if I save it and I commit this, I'll show you what's already in my my Snowflake table. So here I've got the Seha Inc. table, and this table has basically 9 rows inside it, right? Already rows 1 through 9, but the date these were loaded were 10th of February, right? So this is essentially kind of this is going to be my incremental table now. This has rows 1 through 9, but the max load date in this table is February 10th. The other Dallas BI table that has the load dates are from today. So pretty much all the records that are in there are today's load date. So everything is greater. So once I run that, if I go back and I'll run that that dbt command now, to give me the kind of everything greater than that, everything greater than the max load date. This should update my oh, actually it's going to fail because of the tests. No, actually no, test you have to run separate. Okay. So yeah, so the test we run separate. So if you're doing your pipeline, you know, the test that we had, because right now we're doing the dbt run command, we're not doing the dbt test command. So even though the tests are there, it's not failing because we haven't run the dbt test. So when you're running your pipeline, you do your dbt runs and your dbt tests kind of in conjunction if you want to enforce the tests. So even so we go back into Snowflake, and now I do where is that this table. So this should have all the rows that were there before from the 10th, and now it has all these rows that are that were loaded kind of today. So I mean, that's pretty much all the material I have for the demo. I will kind of open it up to any questions anyone has on the topic. I know, Don, your point earlier about, you know, if you have so many dependencies, then you probably want to kind of improve your pipelines. I want to hear kind of more about that, like how you think.
Oh, like the proper use cases that this tool is perfect, but just you know, the projects, the use cases I have. I don't see the tool fitting in on this area. At least I don't need to. Yeah.
So like in terms of the theory of being able to kind of setting up your pipelines and making sure that, like, when you guys architect your pipelines, what's your kind of approach, or from a simplicity standpoint, where once you guys kind of stage data, and then you have to kind of take that data and load it into kind of data sets. I mean, how do you guys structure your pipelines? How many steps do you guys have?
Really depends, you know, if you have a staging of it all, and then you have your refining and your curated and whatever, and then you spin out for based on different BI requirements.
Mhm.
There are multiple, multiple steps. It just really depends on the business needs.
Mhm. But you guys don't have cases where, like, within your environment that you have, I mean, is everything in like one cloud environment? Do you guys run like a Snowflake, or is your ETL tool, like, are you guys like just an Amazon shop and all your with like Redshift, so that you don't have that cloud ingress egress issue, you know, where, you know, or
No, we only have the issue between on-prem and cloud.
okay.
There's no
Okay.
multi-cloud. You know, there might be some other teams and other business that use those multi-cloud, but at least the line of business I'm in, we just use Amazon.
Okay, so everything is within that. And I think that's the thing. If you're running everything in Azure, for example, right? This probably won't be like applicable, right? Because if you've got your database and your ETL tool in the same region, and you don't need to worry about data coming in and out, right? This is not really like a concern, right? Like the selling point that I'm seeing from it, right? That you need that, hey, you run everything in your kind of cloud, and you don't have the charges, you know, ingress egress charges, right? Because it materializes everything in the SQL statements, right? So because if you're an Azure shop, right, and if you're running Synapse and you got your, you know, they give you everything, all the pipelines right there. You just have to worry about data coming in, and there's no ingress charges, right? It's only if you're moving data from one region to another, or moving the data out of the cloud totally, then you incur the charges, right? So yeah, so I think that in the examples that you know, the healthcare examples that I'm kind of referring to, where somebody's a Snowflake client, you know, where they really want to use Snowflake, you know, Snowflake really fits their use case, and Snowflake does not give you all these ETL tools like, you know, Microsoft Cloud, or that's not the business they're in, right? So to do these things in Snowflake, and I imagine probably like in BigQuery as well, is a lot more complicated, right? So a lot of the implementations that I think kind of I've read about, or I've kind of seen, that use the Dbt CLI, and it's all these setups you're trying to do, and with in healthcare, if you're running everything in Azure, that's already high trust. You don't need to do all that stuff with the containers and all that, right? And same with Amazon, right? Like, you don't have to worry about those. But if you have some part of your data living outside whatever cloud you're running on, right? Which, you know, if, like you're talking about your multi-cloud, if you're talking about multi-cloud, right? You need to have applications, or you're moving data from one to the other. How much egress charges are you going to have in that case, right? This is, you can run this a lot cheaper than the charges if you're moving kind of terabytes of data in between clouds, right?
I don't get that part. I don't see this, how this tool can help mitigate the charges among different clouds.
Well, if you need to move data, right? If you're moving data from one cloud to another to do data processing, right? If you're moving data, if you've got data in one cloud system, and you need to do data processing with it in another cloud system, right? That's the example I gave with the Azure data and Azure and Snowflake, right? Like, if you need to move that data out. But if you have other use cases where data, you know, that it may not be relevant. I'm just talking about strictly from a data transformation standpoint, you know? At least that's what I kind of see in this tool. And then you know, like I said, the implementations with Snowflake are, because Snowflake is such a popular kind of data warehouse tool. Implementations with, you know, with Snowflake and DBT are really popular because Snowflake's not giving you, you know, an ETL tool. And now I feel like if customers can get the capabilities of Snowflake somewhere else, you know, then I feel like a lot of the driver to this tool is because of, you know, you can, if you don't want to bind yourself with like an Azure and do everything in Azure, right? You want to use a tool like Snowflake.
Well, the Snowflake is also on Azure.
No, but from an ETL perspective, right? From an ETL perspective, not the storage layer.
Okay.
ETL perspective.
And if you have your ETL on the AWS and you have the Azure hosted in the Azure, of course you need to incur the data minimum charges.
I think even if your storage is in Azure, even still, you need to incur transformation charges.
Yes,
Yeah.
there's still charges.
Yeah. Even still, because you're going to move data from, even your data in Snowflake is in Azure, you move it out,
Yeah.
you know, you do transformation and you write it back.
Right. You still have significant
Yeah. So I think there might have been a comment in the chat. With them being able to. So the question is, how is DBT different than other ETL tools with them being able to extract and load and transform? And speaking of those where the transform is also down without egress or ingress of data. So I think like the templating capabilities, I think are probably something that is kind of unique. But I think you can do those capabilities in other ETL tools. I honestly, I haven't seen other you know, other ETL ETL tools kind of that I've evaluated compared to DBT. I don't think there's anything like feature wise that is extraordinary in DBT that's not in other ETL tools, right? Because I mean, everything I showed, it's like basic ETL stuff, right? Like being able to do you know, create tables, create views, do incremental loads, even like testing, you know, there's other ways to do it in other tools. I think certainly with at least from a testing and, you know, one other thing I didn't really cover here is the documentation, you know, but even like the testing, for example, I think using Azure Data Factory to do some of the tests, I thought there were it's more cumbersome rather than the examples I showed with the testing, right? If you're using but I mean, honestly, you can do all that functionality in other tools. I don't think there's any kind of other difference. I think there was a response. So another question, are there packages for slowly changing dimensions, maintaining and creating? So I think what you're talking about is doing like inserts, like incremental inserts, or doing like upserts, right? So what I've seen within DBT, and this is you don't need like a separate package, right? It's let me actually share my screen. Give me just a second. Is doing incrementals, right? So you have the ability to do incrementals, right? So if you're talking about a slowly changing dimension, right, you've got the two scenarios that I've seen DBT can do are, you know, the one that I just showed, that, you know, you do a brand new insert, you know, you have some marker, you know, in your source dimension that you're checking a load date that, hey, if any new data is there, you know, bring it in, bring it into my target table. The other cases where you identify some unique key, right? Unique ID. And based on that unique ID, you say that, hey, you know, my target table has this ID and this record. If my source table with that same ID comes, I want to do like an upsert, right? Like update that row. That functionality is available using, like, I only show the materialized incremental, right? Where if you have a, you know, where I said that, hey, if load date is newer, if this is incremental, load date is newer, load all the new load dates, you know, in my target table. But using this unique date key, right? This example, they show date key. In my case, it would be that ID column, right? That, hey, this, if I deleted that 8 and made that 8 unique that I had duplicated, that, hey, if this is a unique value, then this does then an upsert. Like it'll identify that unique ID value, and that row it will update. So those are the two I've seen. I haven't seen a way to do like deletions. If you want to do, but I'm sure there's like a way to do it, but it's not like just like a tag you can give and it'll automatically do it. I'm sure there's a way to do like a deletion that, hey, if something deleted from my source, I want it, you know, deleted, or maybe you can do some type of soft delete that maybe have all the deletions that occurred, like compare two tables and see if one table has a record, the other one doesn't, save it into its own separate kind of materialized table and use that to do like soft delete, update like a flag maybe. I hope that answered your question, but you know, and maybe I can, I don't have an example ready for this to show that kind of the you know, updating a record with that unique key, but perhaps something in the meetup I can kind of follow up and kind of share that. You know, that, but like I said, the ones I've seen are kind of doing a brand new insert or having a unique ID and then changing that unique ID's row. But I can follow up in the meetup with an example.
So the language you use to create the models, right?
The what?
Is like, it has a core that's like SQL, but then you can extend it using these kind of
yeah, the template.
special templates.
Yeah, Jinja. Yeah.
That's Jinja on top of it.
Yeah, yeah.
So if you think of a typical case, when you import data, you need to decode values, right? For example, you have a big flat table with 20 codes. You need decode tables to transform the code into a description, for example. How would you do that here? Would you build one big join with, you know, 20 tables, or would you translate that in a sequence of smaller SQL statements, maybe enriched with this Jinja extension?
Can you give that example again one more time?
Yeah, if you have a table with 100 fields, right? And 20 of these fields are numeric.
And these are rows, 100 rows or 100 columns. 100 columns, okay.
100 columns, 20 columns are codes. And you have 20 tables to decode the numeric value into a text. For example, code 001 is medical. Code 002 is dental. Code 003 is something else. When you build your target table, you want to replace the numeric value with the text. So typically what you do a lookup and you store in the target table code and description. If you do that in SQL, you have to join your primary table with the other 20 tables by code. Right? How would you do that here in DBT? Would you do it with one big, you know, join statements with 21 tables, or would you serialize that into multiple statements each time you go and update one of the codes, and then you use the upsert macro, that is, to update the description?
I'm actually not sure about that example, how to actually do an implementation. But if I understand what you're asking is, so you've got a table with 20 columns, like 100 columns, but 20 of them are codes, and those are like what type of rows do they have? When you talk about rows, those codes are like different type of codes within each column, right? And then, so each column has its own rows, and you're saying, and now where are the descriptions stored?
They are typically in support tables, like the code tables, support tables, translation or normalization tables. If you think of planes, right? Planes, they get in.
Yeah, no, I think I see what you're saying. So basically, based on which column you're on, you flip the join. You say it's the same statement, but you have like a kind of like a case statement almost that say that, hey, if you're on this field, you know, join to this table to get the description. If you're on this field, join to this table to get the description.
Well, that's a slightly different, but yeah, that's another interesting case. I was thinking of the base stuff, right? You have 10 codes and you have 10 tables, and those 10 tables, they decode the numeric value into a text. And in the target, because you want to use that in a BI tool, for example, you don't want to use the numeric code because it's hard to understand. You usually want to see the description. So typically what you do is you enrich the final row with a description. And you do that with a join, right? So you join, you know, plain code with a table, plain code description. Provider code, provider description, that sort of things.
Yeah, no, I'll work on that example. I understand what you're saying. I could see a couple of ways to do it, but I need to run through an example where you could do it, because you can do if and for loops, right? So you could have the same.
Yeah. Hey, this is Frank.
Yeah.
I was texting. The solution that he's asking for would just be in one .SQL, Jinja SQL.
Yes.
Because I do the same. I do the same kind of stuff that you do in the DBT, but in Python with Airflow, and I use Jinja SQL. So I'm very familiar with. So you would just write your select statement with the 10 joins, the code to do the lookup on the joins, and then in the select statement you would just use the those tables the descriptor for those columns. That's what I would do, and it'll be just one SQL. You do have to do 10 joins though, unfortunately, for that lookup. It should be more performant, whether it's Netflix, if it's Snowflake or because I've worked in Snowflake and Redshift. I assume those lookup tables are very small too, so it shouldn't be It shouldn't be that non-performant because it has 10 or 20 lookups.
Yeah. No, I'm curious to work on an example like that too. Like I said, I've done more simpler ones, but I'd be curious to work on an example like that and share it. If Frank, in the meetup, if you would like to share something, feel free. But I'll try to work on that example and share it with the group. As
yeah,
well.
I've done some pretty wicked SQL and Jinja SQL, but like I said, it was in Python. I did a template that had all those if blocks that you're talking about, and it was over 3,000 lines of code. Now, don't tell me why it was. The business logic was really bad that we had to do.
Underlying,
but when
converting into Python as well, right? Like underlying when you write,
yeah,
it's like Python based.
Yeah, Jinja SQL is this by Python package, right? And it's exact same what you were showing there.
Yeah.
And it's 3,000 lines of code, but when it dynamically generates that SQL, the example I was talking about, it builds only like 500 lines of SQL. But it was all done in one Jinja SQL statement. Now with DBT, what I see with those modules and the references, the reusability of that, it makes it simpler. So it's not like it. You can have like all those subqueries or CTEs as its own models, and then you can just reference them, and then it makes it more readable. Then instead of putting it all into one like model, right? One Jinja SQL. That's how I see where it makes it easier in DBT versus like putting it all in like Python.
No, thank you for that comment. And I think you asked another question about running a define or mark or set a model to run as a transaction. I wanted to understand what you meant by that. You meant like a schedule, or
let's say you have a pipeline, right? So you schedule and it's like, hey, I want you to run this module, this module, and this module in this order, because I need you to go in this sequence like a workflow. and I want it to be run like in a database transaction. So it has to say, hey, begin transaction. If something happens, hit rollback, else hit commit.
Mhm.
That's what I meant by transaction. If it's doable in a DBT somehow where you can, when you define it or when you run in your command, DBT command, or I guess DBT can be kicked off and run in Airflow, and then it calls the DBT commands. I guess you could, I don't know how the database connections are run, because I assume if you use Dbt Cloud, the database connections are created in a database connection pool or something within the Dbt Cloud, and then it's running, it dynamically generates the SQL from the models, and then it submits them to Snowflake, right? In the order that you wanted them to, right?
I can share the, like, it seems you've worked, quite a bit with it, but the way I've seen it.
No, I haven't worked a lot with Dbt yet. I've worked with a ton of different ETL tools and hand coded it all. So I'm trying to.
Because I think the way what you're asking, so it's one thing is setting up a pipeline and scheduling, right? Like each when you set up a pipeline, it's going to have each individual kind of command that's running each of individual model, right? But all those models are ultimately being converted into some type of SQL statement, right? And that SQL statement is what's being sent to Snowflake or any of your platform.
Yeah.
So whatever transactioning capabilities are enabled on that SQL statement are going to carry over into DBT, because no real kind of transactions are in DBT other than sending the command over, right?
Yeah.
The transactional capability is in your underlying database. So I'll show you all the stuff we ran today, right? It's basically literally like all the
the one that we do was simple. I'm talking more like really advanced one where you have to get
right? The concept
the
is,
concept.
I'm just doing a select star, right? Or no, actually, this is what I did. Well, let me do the insert one, right? I did insert into dev, ID, patient name, ID name, and from here, and it created like a temp table here. That incremental load that I did, it in the background, it converted it into a SQL, right? And those SQL statements then ran against the Snowflake engine. So
yeah, those are atomic. When it runs against Snowflake, it'll be atomic. So every time you call it, it automatically does a commit, just like it would do with Redshift. But there are ways where, I guess, if you do an order, you can make a SQL statement that says begin transaction A, because you can start like a actual transaction in Snowflake
in a
or Redshift.
model, I don't think you can define that functionality, right? Because a model ultimately has to create a select statement, right?
And those select statements would have to run it within the same database connection and session too.
Yeah. But so I mean, what is your like? Are you trying to get around that session or trying to get around that?
No, I can't. If I have to run it as a transaction to make sure that A, B, and C gets run in a certain order, and then they all have to be successful. Because if something happens and it fails, let's say I did a merge statement. So in Snowflake, you can do a merge statement. In the merge statement, if the feeding source gives multiple values to go into one record, what you're merging on, it's going to throw some weird error unless you set your session in Snowflake to something else. I've had this done before, but it doesn't happen. Like Redshift handles it somehow, but the Snowflake does it a different way, and so it would throw an exception. So if it throws an exception, and you're in like you're doing A, B, and then C, and that was C, and then if that failed, you want the whole thing to automatically call rollback. Rollback. So then it just throws the exception, it rolls it back, so they're not committed.
Right.
If that makes
With
sense.
Tests, right? Like with the test, like the way we did it, I just did a DBT run, right? But if you run a pipeline and if you have tests set up, right, that says that, hey, if this happens, this pipeline should be, it won't commit the run. It won't commit the model if the tests fail, right?
Yeah, but then there's a problem, like the test can fail in the beginning, and then you got someone giving bad data, and then they have like duplicates in there because like Snowflake and Redshift doesn't, like you said,
it doesn't
enforce the constraints. So I've had clients where it was defined for the primary key, and we're copying data from Redshift over from Redshift to Snowflake in a migration, and the data finally comes over to the stage table that brought it into Snowflake, and then it does a merge statement to the final table that we put in like a schema called raw, and then it moved it over, and then it blows up because there was the unique constraint, the primary key was not enforced because it wasn't enforced and there was duplicates, which is bad. It's just
So we're saying
bad.
basically within the same model, as the model is running and it's
Mhm.
committing each
Yeah,
individual row, how can you do a rollback if they send you bad data?
Yeah, if it's
And if your
possible that
test doesn't
somehow,
catch it, and if your test doesn't catch it, or you don't have a test in place to catch it.
yeah, or there's a way where you run multiple models, like you ran, like you, in your thing, you say, hey, DBD run, and then the model folder, and it would run all your models, you
Yes,
said,
yes.
right? All your .SQLs. How can you say, is there a way also when it runs it that you can do the order? I'm assuming that you would pass in if you needed it, and you would put it in a specific
if you
order.
remember how we showed that ref function?
Yes.
Remember that ref function? If you're
Mhm.
referring to tables, right? If you're
Mhm.
referring to,
Mhm.
if you're referring to tables instead of the table names, you're referring to
Yeah.
them in that ref format, it's going to actually show the lineage, and it won't run a table until its dependencies is run, right? So in my case here, if you can see my screen, I've got the Dallas BI test and the Seha Inc. Because I've used the ref function, it'll automatically do, right? But your example about within the transaction, it's within one model and each and every row, that I don't know. How you can do that without having a test, right?
Yeah.
I know you can add a test and it won't run. But if you don't
so if you had in
know,
your models a bunch of dimensions in the .SQL, and then you had your fact table, since your fact table is doing lookups to all the reference to the dimension models, the fact table would be run last. If you ran like what you said, what you just said, DBT run this model, it would run in whatever order in parallel.
as long as you reference whatever reference it has, like you have a fact table, you've got 20 dimensions and you got that references 5 of them. As long as it's referencing it, you have the ref tag, it'll automatically check those 5 are run, and then it'll process those using this kind of DAG that it builds in the back end. But if you don't have a test in place to check for what you're checking in advance, I don't think you can enforce it at the transaction. I'll have to check that. I'll have to research that one.
One strategy would be to break it up in small models and run them all, right? So you can track each individual model.
That's true. Yeah.
Success.
Yeah.
And you stop it and roll it back.
But then you run into the problem that I know, Don, you're against, is like you don't want too complicated pipelines, right? Because if you wanna consolidate your pipelines, then if you do it if you break your models further, it adds more kind of, it helps with like troubleshooting, but it would add more in terms of more models to kind of maintain in your project, I guess. But yeah, that could be something. But it's all, I feel like the testing would work if there are things right? If there are things you can anticipate. But if you don't know what you're looking for to code in advance, then it would be harder. But thank you for those questions, Frank. I appreciate it. And I will try to come up with that example. I understand your example, but implement it with Jinja and try to like share it, in the meetup.
Yeah.
I appreciate it. Thank you so much, everyone, for joining. I hope it was useful. I'll upload the presentation and the recording, and I'll follow up with that example, via the meetup. Thank you, guys. Have a good one. Bye.